Yes.
Now we are seeing one image. What you identify from this image, what you see, what you get the uh, what is your output of this image? What is the features you are looking? It's look like a face looks right, isn't it? But it is also a face looking towards you also. Okay. So I'll show another picture. This picture is if you see this, you can have two types of observations. One is a lady looking backward, or a old lady looking down. Can you able to see that? Okay. Now it is another image. What is this? Can anyone open the mic and tell also? No problem. Or you can type it.
Rabbit
It's like a rabbit. Very good. Any other answer?
or a duck.
Or a duck. Or a duck. Very good, sir. Thank you. So this image, this looks like two faces are merged. You have two eyes and two lips. So it's like that. So there are lots of, so why I'm showing this types of picture is, so we are not seeing the whole image. When you see any image, we are seeing only the features. We are not seeing all the informations in the image. All the informations are added for better appearance, but basically our eye captures only the features. The similar way, the machine or the robots or any other detecting algorithm has to find only the features. It has to it uh, it, it should be interested only on the features, not on the overall images. For example, this hair, this background, that face, total face. We should the algorithm that we are going to design should be focused only on the features, the main features for the detection purpose. So CNN is one of the most popular neural network algorithms. It is comes under deep learning in the AI, and it produces better performance nowadays. So how it will work? So if you take the input image, if you pass that to CNN, you will have the output. For example, this is the image, smiley image. It has some features, right? So basically, we look only on the features. So what is the features? Eyes, nose, and lips, and the mouth. So these are the features we are interested. And my algorithm has to identify only that features. So our eye is also like that one. Our eyes only looks for the features. It's not looking all the informations. So when you apply these to the CNN based on these features, it says it is an happy. Based on these features, it says it is a sad. So my aim is not to um, talk about completely about CNN. We need to know what is CNN, and then we will apply that to our image. So if you take a image, it is a 2x2 image. If it is a color, you have RGB plane. If it is a gray hair, you have only one plane, the two-dimensional array and three-dimensional array that we know. This is the pixel representation of this smiley image. So other part are zeros, and the part that is in the eyes, nose, and the lips are black one that is represented as 1. So it is nothing but 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 cross 7. Okay, I'll move it quickly. What are the steps that we are using in the CNN? One is convolution, max polling, flattening, full connection. So neural network is creating a network like our brain. We have nodes, the input nodes, the input layer, hidden layer, and output layer. All those are connected with a connection. So finally, you will have a full connection. So before that, we are going to apply convolution on your image, and then we are going to apply max pooling, and then flattening, and finally, we are resulted with a neural network for that particular image. So what is convolution? That we know convolution is nothing but multiplication of two things or integration. So if you say here integration. Okay. Integration of two functions. Let's see how it is happening in my image. So this is a smiley representation, that is my input image, and we have the another function that is called feature detector. So this is one feature. Now we need to multiply these two. Okay, convolution is nothing but multiplication. So I am applying the convolution on this particular image. So this is 0, 0, 1, 1, 0, 0, that is the feature, and I apply this to this part, the same size, 3 cross 3, 3 cross 3. When you multiply 1 by 1, 0, 0 is 0, 0, 0 is 0, 0, 1 is also 0. Okay. After that, 1, 1 is 1, 0, 0 is 0, 0, 0. So when you do the bitwise multiplication over this, you will get 1 at the output. So next, this feature has been slided one step. Then again the multiplication will take place and the result will be there at the output. Next step is again it has been pushed one side towards right, and then multiplication will take place. So like that, it will move step by step, and then one point downward. Okay, so like that it will go. So now we can see this case. If you multiply this area of the image with the feature 0, 0, all first row is 0, second 1, 1 is 1, so there is 1, and here also you have 1, so you have 2 here. Okay, so then 4 you are getting. So after applying this, you will have the feature. After applying this, you will have the feature map. So this is called feature map. So your input image has been multiplied with the feature detector, and then you will have the feature map. If you see the last part here, you will have lots of feature detections. You may ask how these feature maps are coming. The reason is we are applying many, we are not applying only one feature detector, we are applying many feature detector. We have discussed on the R cascade, we have lots of feature detectors. So one is rectangular, another one is triangle, or different shapes, different values are there. Okay, so there is lots of feature detector. After applying all the feature detector on the image, you will have feature map, that is called convolutional layer. Okay, so the first step is we are creating the convolution layer. The next step on this one is we are applying the activation function over the convolution layer for non-linearity. So when you are studying the neural network, you will have the activation function also. Okay, the reason for the activation function is for the to accommodate the non-linearity of the images. Okay, so this is the original image. After applying the convolutional network, you will have the images layer. You can see only the features. not the overall information. So the sky and all. Only thing is we are interested only in the future because the future determines the information of the images. So that is the thing. And the next thing is max pooling. Why we need to do the max pooling? You can see there is some pictures of the cheetah. One is looking straight towards us. One of them is little bit of tilted. Another one is little bit of shrinked. So there are different forms of faces. Here also you can see there is some cheetah sitting on the floor, running, sleeping. Okay, long shot. So there are different forms of images. Our aim is to identify the cheetah. For example, I'm taking. So for that, to identify that, we are going for max pooling. So what this max pooling does is, this future map will be passed into the pooling. So what this pooling basically is, there are different types of pooling. One is max pooling, min pooling, okay, sum, average. Okay, so there are lots of pooling method. We can choose anything. There are many types. Sum pooling is there, mean pooling is there. Okay, this image has been converted into this 3x3, this future map. Let's see how it is happening. So what I'm going to do is, I'm going to do the max pooling. Max pooling means in that 2x2, I'm going to take only the maximum value of that. So what is the maximum value of this one? Is 1. When I shift it, what is the maximum value? Again, it is 1. And I shift it, again the maximum value here is 0. When I shift it down, what is the maximum value over here? It is 4. When I shift it again, the maximum value will be 2. So if you take sum pooling, you have to sum. So there are different types. You can choose anything. You can work on that max pool, min pool, like that. Better result you can take for that image. So just I'm giving the overview of convolutional neural network. That's after that. So what we have done so far is input image. After applying the feature into it, we'll have the convolution layer. That is the feature map. It contains only the features. After that, I'm applying the max pooling and I'm reducing that. It contains only the informations in the 3x3. The next step is flattening. What this flattening is doing is, the huge information, that means 8 7x7 or 8x8, 16x6, whatever it is, has been reduced to this size. Okay, now you can see this rows are converted into columns 1 1 0 4 2 1 0 2 1, like so. Okay, so that is the flattening. After this flattening, you can see these are the nodes. We are applying that to the neural network. That's a convolutional neural network. In this neural network, that flattening output will be given as a input. That is the input layer. And then you will have fully connected hidden layer. You may have many hidden layers also. After that, fully connected means every node is connected to every hidden layers. Finally, you will have the output. That is from the hidden layer. So this is a convolutional neural network introduction, or the working of convolutional neural network. And there are something like back propagation. This there to increase the accuracy of the detections, and lots of things are there. That's all comes under theory part. Okay. So that's all about convolutional neural network. So 4 points are very important. One is convolutional, and then you have pooling as well as flattening, and finally you will have the input and output layer. It will does our, we can apply that for our image. So that is how it is working. If you understand that, we'll move on to the coding part. So that's a quick introduction about CNN. Open the code. So today I have sent one file So download that file and upload it on your drive. That file name is, I have uploaded here on my drive, MMOD underscore human underscore face underscore detection. So that is the file name that I'm going to work on that file. That file, that is nothing but that file. You can't see that. Where you can see that file is, there is some resources for that. You can. This is face detection with DLib, HOG and CNN. So here also you can have some information. Yeah, this is the GitHub. So you can download from MMOD, human face detector.dat. So this is a file. Now we move on to the CNN. The first step is we have to import the image and then that MMOD human face detector dat file. So people 2, where is people 2? Here is my people 2, copying the path and I am pasting. For reading the image, we are using CV2. CV2 is computer vision library. And we am creating one variable called CNN underscore detector. DLib is the library that I am going to use. In that, when you type, I'll show you. CNN underscore, you'll have face detection mode. There is cross-valid sequence segmenter, Chinese whisper, a lot of things are coming. So I am interested in face detection mode model V1. After that, I am pasting the location. What is the location? Mode that copy path. Pasting. That is the dat file. I'm just running that. So now it is created. So this face detection model using this mode face detector feature selection. Okay, so that you have to mention. After that, detections. CNN, that is the detector, trained detector with that file. After that, we are giving the image. Finally, we'll see the detections. Let's see what is the output. It's not showing anything. You know what is the reason? I'm not giving the image. You have to detect the image. Here we have the mode rectangles, but there is no values. Again, we have to check it with the scale factors. So we have to give 1. Now you can see there is lots of detection. Let's see how much it is. Len dot detections. When you run it, we have 14. So it is also detected the 14 phases. So if you want to see the 14 phases, again, we have to do the same part that we have done for the fog, that for loop and all. I'm just copying this and I am pasting over here. So the only difference here is there you have for phase.top, but in CNN it is a little bit different. Phase.rec.to over here. That's all. Other than that, all are same. I'm just running that code. Okay. So now you can see here there is one extra C. Left, top, right, and bottom. There is one C. And I printed that value over here. This is the C value. What is this C is nothing but it is a confidence value. When you are using neural network, there will be confidence. Confidence value will be there. The confidence value tells us the quality of the detection. If the confidence value is high, then you can say the quality of the detection is high. When the confidence value is low, you can say the quality of the detection is less. So that is the factor. Okay. So now you can see all the 14 phases are detected, and you can see the confidence value is also above 1. There will be less value or negative value will be there. That shows the confidence value is not good. So for this particular image, you can see the CNN and OG is performed better than R cascade. Okay. So that is the thing. So if you want to use, if your R cascade is not performing well on a particular image or in the applications, you can try out OG or you can try out CNN. Finally, now we come to the comparisons of R cascade, OG, and CNN, and we will see which one is performing better. So for that, I'm going to use, for R cascade, I'm going to use people 3. So for all these 3 methods, I'm going to use people 3. So people 3, you can take from our image folder, copy path, and then you can paste it. And the next thing is I'm converting that to gray. And I'm applying R cascade. For R cascade, I have to use cascade classifier, and then I have to upload the XML file into it. Okay, frontal face. So I'm going to detect one of the frontal. So what is people 3 image? You want to see that means you can click on the image. This is the image. People are standing. It's a zoom out image. Let's see how the algorithm performs. Just copy this and paste it the location. And you have some parameters over here. So 1.001 min neighbors, min size. Just run it. It will take some time. Now you can see this. The detection is only one face is detected. That too, it is not only face. There is some background is also, it is detected some of the background also. If you reduce, since the faces are very, very small, what does it mean? We have to reduce the scale factor. So already the scale factor is reduced to 1.001. Okay, the maximum value should be 1. It should not it should not below 1. So since the phase are less, so we are dealing with small scale factor value and minimum neighbors. I am reducing the quality also since there is no detection. Okay, min size is 5 and 5. That's obviously good because it is small size phases. Now let's see whether we can have the better result. So we have not resized the image since already the phase is less. So we are not resized the image. So it is taking little bit time for processing. Now the output is there. You can see there is some more detections, but all are false detections. There will be no betterment in this. Okay. Now we go to the org. For the same image, we are going to do copy the location of the people. The same thing. Hog dlib we are using get frontal face detector. I'm not going to put 4. I'm giving 1. Okay, let's see the output. When I give 1, there will be no detection. Like a similar to scale factor, this one. So I'm increasing that to 2. Then you can see this is a little bit faster, right? When you compare to R cascade, hog is little bit faster. That is also one of the advantage of hog. Because there is lots of features, feature selection is taking place here. That is not the case. It is in the form of histogram. We are applying the mathematical concepts. So it is a little bit faster. This algorithm is faster. So when I give 3, 1 phase is detected. When I give 4, how many phases? 1, 2, 3, 4, 5. 5 phases will be detected. It's good. So let's increase to 5. Your session is crashed. Okay. CV2 is not defined. So that means you have to go to the top.
First cell, first cell.
Yeah. That library function is not detected. Okay. So main difference, one of the drawback in the Google Colab is you cannot use the Google Colab for real time applications. So for studying purpose, for research purpose, you can use it. So if you want to do some real time detections, for example, I'm speaking in the camera. If you want to detect means you cannot detect that using Google Colab. Okay, my system is taking some time. So meanwhile, I can move to the CNN part. Again, the same thing. So for CNN, we need the mode face detector. Mode face detector is nothing but min max file. dlib is not defined. Okay. So all the library functions I have to do it since it's not connected. And now it will work. Wait a minute. CV to IM show. Okay. Now we can see the same 5. Okay. If you increase that to 5, second. Okay, again the session is restarted. So 5 is showing some error in my system. Okay, no problem. So you can work on this like that. Okay, no problem. So I can run all the codes, but it will take more time. That's why I'm selecting the particular command. Okay, we'll just check out about CNN and then we will find out. Okay, okay. Sorry. Okay, now we can see the output of CNN for the same value of 4, it has only 2. That too, the confidence value is very, very less. It is around 0.4 or 0.08. So for this particular image, Hog performs better than CNN as well as R cascade. Usually CNN is better than Hog, they are saying, but it all depends on the application and the images. For some of the images, CNN may perform better than Hog, but in this case, Hog is performing better than CNN. You can try various images. There are different types of images I have sent. So you just work on different images and you work on different algorithms also. So here you can see there is 5 phases. So that is the comparisons of R cascade, Hog and CNN.